Hello friends, myself Rajendra Mahajan presenting my video on linear differential equation. Case number 4th, solve differential equation d raised to 4 minus 2d cube plus d square operated on y is equal to x cube. And as the term on the right hand side is x cube, it is of the type x raised to m. Case number 4th for finding pi. And therefore, to obtain the solution, we first write down the auxiliary equation. Auxiliary equation is equation in terms of d. Therefore, that equation is d raised to 4 minus 2d cube plus d square. We have to equate it to 0. And as it is, its degree is 4, we are getting 4 roots for d. And therefore, to obtain that 4 roots, we take a d square common from all this. We get d raised to 2 as common. Remaining term is here d square minus 2d plus 1, and that is equals to 0. A product of two terms is equals to 0. Equating each term to 0, we get d square is equals to 0, and second d square minus 2d plus 1 is equals to 0. From first we are getting 2 roots, as d is equals to first one is 0, second one is also 0. Therefore, a real and a repeated roots. And the second factor is d square minus 2d plus 1, and that is equals to 0. This is nothing but perfect square of d minus 1 whole square. Equating each to 0, we get d is equals to 1 and 1. Once again, 2 real roots and a repeated one. And therefore, using these 2 roots, 2 sets of roots, we can write complementary function as, for this real and repeated root, a way to write is c1 plus c2x multiplied by e raised to that root, that is 0x, and plus again a repeated roots. Therefore, next constant c3 plus c4x into e raised to that root is 1 here, and therefore 1 times x. And we call this equation number 1, CF. 1 mark for this step, if all steps are correct. Then next step, we require to find out particular integral by inverse operator technique. Here that operator is 1 upon d raised to 4 minus 2d cube and plus d square, which we have to operate on x cube. Then, as it is of x raised to m type of term, we have to take the lowest degree term as a common from all this. Therefore, the degree of first one is 4, second term is with degree 3, and the last term with degree 2. And therefore, this term we have to take as a common. Therefore, 1 by d square I will take common, and 1 upon. Remaining terms we write from right to left direction. If we take d square common from d square, remaining is 1 minus. From d cube we take d square common, therefore remains 2d. And from d raised to 4 we take d square common, therefore remaining term is plus d square, which we have to operate on x cube. Then it is 1 by d square, as it is no change. Then transferring this term to a numerator by taking minus common from these 2 terms. Therefore, we get 1 minus. The term is here 2d and plus d square. Therefore, already I have taken minus common. Therefore, the remaining term with a minus sign, minus minus, it becomes plus. Therefore, it is d square with minus sign. And as we are transferring it, it becomes raised to minus 1, which we have to operate on x cube. Then expanding this bracket by binomial theorem. Its expansion is, therefore, what binomial theorem we have to apply? it is 1 minus capital X raised to minus 1 as 1 plus capital X plus capital X square plus capital X cube and so on. And we have to expand this bracket up to d cube, means term containing up to d cube only. Therefore, that pi is equals 1 by d square, no change. 1 minus capital X raised to minus 1, the first term is 1. Then plus x, x is here, 2d minus d square. Then square of it, therefore plus 2d minus d square and whole square. Next one is the cube of that, therefore plus 2d minus d square and its cube and so on. Which we have to operate on x cube. Then expanding each and every term and considering the terms up to d cube only, means neglecting d raised to 4 and higher order terms we have. Therefore, that particular integral is equals to 1 by d square as it is, no change. First term 1 as it is, no change. Any number raised to 1, we get the same number, and therefore the expansion of this bracket 2d minus d square remains the same. 2d minus d square. Then it is a minus b whole square. Its expansion is a square minus 2ab plus b square. And as per that, it becomes square of this first term is, it is 4d square minus 2ab, 2 times 2 means it is 4d cube, and square of this last term, therefore d raised to 4. These are the three terms from the expansion of this term. Then a minus b whole cube. First term is a cube. Therefore, the cube of this first is 2 cube means 8d cube. 3a square b. Therefore, 3 to the 6. A square means d square and b is d square. Therefore, that becomes d raised to 4, neglecting that term. Next one is 3ab square. Square of this is d raised to 4. Again, we have to neglect it. And plus b cube. Cube of this d raised to 4. D square is d raised to 6, neglecting it. Therefore, we have to take only one term, that is 8d cube, from the expansion of this bracket. And so on, which we have to operate on x cube. Then it is equals to 1 by d square, no change. Operate term by term to that x cube. Therefore, 1 multiplied by x cube, we get the same term, x cube, times d of x cube, means derivative of x cube with respect to x. Its derivative is 3x square. Next minus d square. Next derivative of this. First derivative is 3x square. Next derivative is 3 to the 6x plus 4 into d square of x cube. Second derivative is 6x. This is minus 4d cube plus 8d cube. We get plus 4 times d cube, means third order derivative of this x cube. This one is the first, this one is second. Therefore, the next derivative of 6x is 6. And d raised to 4. Fourth order derivative of this. Or the next derivative of 6 is 0, as it is a constant term. We stop here. And then it is 1 by d square, as it is, no change. X cube as it is, 3 to the 6 x square minus 12x and 6 for the 24x and plus 24. And 1 by d square, if d stands for derivative of that function with respect to x, 1 by d stands for its integration. And therefore, we have to integrate twice. Therefore, I will split that 1 by d square as 1 by d into 1 by d. And that 1 by d, nothing but integration of this term, x cube plus 6x square, 24 minus 12, we get plus 12x and plus 24. which we have to integrate it with respect to x. Performing this integration, therefore 1 by d, again integration of x cube is x raised to 4 by 4 plus 6x square. Its integration is x cube by 3 plus 12. Integration of x is x square by 2. Integration of 24 is 24x, which we have to again integrate with respect to x. And therefore, integration of x raised to 4 is x raised to 5 by 5, and into this 4, 5 4 the 20 to the 6 2 times. Integration of x cube is x raised to 4 by 4, by 2 we get 6. Integration of x square is x cube by 3 plus 24. Integration of x is x square by 2. Therefore, we get a first one as x raised to 5 by 20, no change. 2 to the 4 we get. Next one as x raised to 4 by 2. 3 to the 6, 2 times x cube, and again 24 by 2 we get 12x square. We call this as equation number 2. Correct, then only you will get that 2 mark. And last 1 mark for addition of equation 1 and equation 2. Therefore, that solution is called as complete solution. Nothing but CF means equation 1 plus PI equation 2. And complete solution is always for the dependent variable. Here the dependent variable is y. CF is C1 plus C2x e raised to 0x, C3 plus C4x, and e raised to, this is equation number 1. With this equation 1, we have to add this equation 2, that is pi, and therefore adding this we get plus x raised to 5 by 20 plus x raised to 4 by 2 plus 2x cube and plus 12x square as the required solution. Therefore, once again I will repeat, a complete solution is the addition of complementary function and pi, particular integral. CF is C1 plus C2x plus C3 plus C4x into e raised to x, and the particular integral is x raised to 5 by 20, x raised to 4 by 2 plus 2x cube and plus 12x raised to 4. Whatever this we have is called as the solution. Solution nothing but a relation between dependent variable and independent variable x with some arbitrary constant. That arbitrary constants are here C1, C2, C3 and C4, 4 arbitrary constant. One more I will discuss in my next video. Please like my video, share it, as well as subscribe to my channel. If you are not subscribed yet, please subscribe it. And to receive the notification for my all such type of new videos, please press the bell icon. Thank you. Thanks for watching.